In this last example, if we're looking for sine, first thing I want to focus on is the beginning and end of a period. But based on the points that I can see, I can only really see this interval here from negative pi to pi. So if I compare that to my original sine graph, which looks something like this, right? I see that this piece correlates to this piece, which means that we only have half a period of sine. So we'll keep that in mind when we're calculating our period for this transformation. So we begin the same by doing our amplitude, which is our highest y value minus our lowest y value divided by 2. Our highest y value is 2. Our lowest y value is negative 2 divided by 2, which is 4 over 2, which is 2. That's our A. Next, I need to do my vertical shift. That's high plus low divided by 2. 2 plus negative 2 over 2 is 0 over 2, which is 0. So this is our D value, and if D is 0, there's no vertical shift. Now I'm going to find my period. Now remember, from negative pi to pi is half of a period. So my period is going to be double the distance between those two values. Pi minus negative pi, the difference between those two, will give me my period, or half of my period. So that's 2 times 2 pi, which is 4 pi. So that tells me that 4 pi equals 2 pi over b, or b equals 2 pi over 4 pi, pi, which is 1/2. So now if I'm looking for my shift left or right, this point right here, if we look at this, is actually the beginning of my sine curve. And that always starts here at 0. So we have no shift left or right. So that'll tell me C equals 0. And also, looking at this same graph, I start at 0 and I go up. Same thing as my original parent graph. So there is no reflection. So if I put this all together into a function, y equals sine of some stuff, I'm going to have 2 1/2 x minus 0 plus 0. And remember, we don't need those zeros, so I can write it as 2 sine of 1/2 x. And that would be the graph of this transformation.